these look so intimidating. I can't do these. Yes, you can. Of course you can. We're just not going to do number 1 first because that one is a bit much. But let's look at number 4. They're really not that bad. Okay, I'm going to walk you through it. So let's start off with an easier one, and then we'll work our way back to number 1. Okay, so check out number 4. So today is a little bit different than yesterday because yesterday only one side I kind of had to rewrite, and some of them were already fine. I didn't have to do anything. But here's the problem if you're looking at number 4. If I tried to do the same thing that I was doing yesterday, if I wanted to rewrite 125 as 25 to some exponent, it doesn't work, right? 25 to the first is 25. 25 squared is already 625, not 125. So what do I do? Well, think about maybe some other numbers that 25 and 125 have in common. Like maybe, I don't know, I'm hoping that 5 is kind of jumping out at you. Isn't 5 squared equal to 25? And isn't 5 to the third equal to 125? Oh, okay. So what I need to do is I need to, instead of leaving my base as 25, I'm going to have to rewrite both of them so that they both have because that's my ultimate goal. I want them to have the same base. And then I can just set those exponents equal to each other. So what I'm going to do is I'm going to rewrite 25 as 5 squared, and I'm going to rewrite 125 as 5 cubed. All right, now watch how this works. So on the right hand side, rewriting 125, that's easy. But on the left hand side, you have 25 and you're raising 25 to the 2m power. So you need to be really careful here. You're going to do 5 squared, but then you're going to raise it to the 2m power, like that. Does that make sense? Because I'm taking 25, right? And I'm raising the entire 25 to the 2m power. So I need to take my entire thing here, 5 squared, and raise it to the 2m power. So now what I can do is I can kind of simplify that left-hand side. I'm raising a power to another power. So remember, I'm going to multiply those exponents together. So I really get 5 to the 4m equals 5 to the third. Do you see that? And now I can just set those exponents equal to each other and solve. 4m equals 3, so m must be 3/4. Okay, hopefully that kind of makes sense. All right, so let's try, let's see how 3 is. 3 is a bit much yet. Let's do 6 next. Okay, so taking a look at 6. All right, I'm thinking about 216 and 36. Don't worry about the 36 being in the denominator just yet. Let's just think, what number could I write 36 and 216 as raised to some exponent? What can I do here? Well, 36 is certainly 6 squared, and it turns out that 6 to the third is 216. Okay, so even if you want to jot that down, 6 squared is 36, and 6 to the third is 216. Oh, let's write it as 216. What am I doing? 216. There we go. Okay. So now let's see. 216, I'm going to rewrite it as 6 cubed, but then I'm going to raise it to the 2m power. Right? Now, over here, this is not 36, it's 1/36. So it's not just 6 squared. How do you get the 36 in the denominator? If 6 squared is 36, then 6 to the what power would get me 1/36. So it looks like it's got to move to the denominator and it's got to be squared. So hopefully you're thinking, ding, 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 -2. Right? Isn't this true? 6 to the -2 gets me 1/36. So if it's in the denominator, I'm going to have to be using negative exponents. So I'm going to rewrite 1/36 as 6 to the -2 power. Okay, and now I'm ready to rock and roll. On the left, that's going to get me 6 to the 6m. On the right, that's 6 to the -2. So now my bases are the same. I can set the exponents equal to each other. 6m equals negative, I'm going to do it up here because I'm in a room. 6m equals -2. Divide both sides by 6. So looks like I get a -1/3 as my final answer. Okay, so now let's rewind and let's try. Okay, I think we can do number 2 now. So 125 and 625. What number could I write as exponents to represent those? Maybe you're thinking about, I don't know, 5. 5 cubed gets me 125. And 5 to the 4th just so happens to be 625. All right, cool. So 125 now becomes 5 to the 3rd, and then I'm going to raise that to the -3b. On the right-hand side, I want 1 over 625, so that's got to be 5 to the -4th, right? That's how I would get it into the denominator. Oh, okay, I'm getting the hang of these. This is not so bad. So on the left, that's 5 to the -9b. On the right, that just stays 5 to the -4. Let's set those exponents equal to each other. -9b equals -4. Divide by a -9. B is just going to be 4/9. All right, all right. Okay. I can do this. All right, let's go back and try out 1. It looks super intimidating. It doesn't have to be, right? It doesn't have to be. Let's just go piece by piece. So we're going to look at the 81 and the 27. Let's start with those. What number can I write to an exponent to get an 81 and a 27? I'm hoping you're thinking about 3. 3 to the 3rd is 27. 3 to the 4th is 81. All right, all right. So I want, let's just look at the left-hand side. I don't want 81, I want 1 over 81. So that means that instead of writing 1 over 81, I'm going to write it as 3 to the -4th. Isn't 3 to the -4th the same thing as 1 over 81? It is. They're exactly the same. And then I just leave the 3p plus 2 right there. Okay, all right. Now I do the same thing with 127. 1/27 is the same thing as 3 to the -3rd. And then I'll just raise that whole thing to the 3p power. Okay, so now let's just simplify each side. I'm going to raise my exponents. One thing I do want to point out here, you need to distribute, right? You're going to multiply this whole thing by -4. So you need to distribute to both, right? So you're actually going to get 3 to the -12p minus 8. And then on the right-hand side, that'll be 3 to the -9p. All right, cool. Bases are the same. You're ready to set your exponents equal to each other. So -12p minus 8 is going to equal -9p. Let's go ahead and solve. Add that 12p. -8. What's that? 3p. Divide by 3. I'm getting -8/3. I don't know about you, but that's what I got. Okay, so even the intimidating ones, they're really, if you just find what that number is, right? Find the number that you can rewrite them as, so we were looking at 81 and 27. So actually, that's a good point. You might have thought when you see 81, you're probably automatically just thinking about 9 because it's 9 squared, right? But there's no way to write 27 as a power of 9, right? So that wouldn't work out. So then you got to think, oh gosh, okay, I can't use 9, but don't forget about 3s, right? 9s and 3s, and they are always connected to each other, right? So okay, we'll do one more together. What the hey? What the hey? We'll do 3. Why not? So I'm looking, I'm seeing my numbers here. I'm going to focus on the 2 and the 64. Well, I can actually write 64 as a power of 2. So that's kind of cool. All right, so let's see. 2 to the first is obviously 2. And then 2 to the, what is it, 6, the 64, is that right? Yeah, 2 to the 6th. So now let's look over here. I don't have a 2 here, I have a 1/2. So when I rewrite this, I need to write it as 2 to the -1, right? That's the same thing as 1/2. And I'm going to raise that to the x power. Does that make sense? I hope. Because remember, I'm not using 1/2 as my base. I'm using 2 as my base. So I have to rewrite 2 so that it looks like 1/2. Or I have to rewrite a half so that it has a base of 2. All right, 64 is going to be 2 to the 6th. So I'm going to take 2 to the 6th, and then I'm going to raise it to this -x minus 3 power. All right, so on the left, I'm going to get 2 to the -x. And then on the right, again, you're going to have to distribute, so be careful. So that's going to be 2 to the -6x minus 18. Now I'm ready to set those exponents equal to each other. -x equals -6x minus 18. And we can boogie woogie here. We got 5x, -18, divide by 5. I've got a -18/5. Do you? Look at you go. Okay, try the rest. Let me know if you get stuck.